Slopes tell us the rate of change of y with respect to x. The slope of a secant line between 2 points gives the average rate of change of y with respect to x. The slope of the tangent line, the derivative, at a specific point gives us the instantaneous rate of change of y with respect to x at that point. So if we were looking at this scenario, let's actually use that to kind of understand and interpret this in the real-world applications. So h of t gives the height of a ball after t seconds has elapsed. Interpret h prime of 1 equals 64. Okay, so again, this is the slope of the tangent. So if we've got the height is the y values and the time is the x values. So that slope of that tangent is going to be the change in height, because it's the change in y, over the change in x, which is time. So what this means is after 1 second, the ball has a rate of change, which in this case is going to be velocity, because we're talking about the speed, so how quickly that ball is moving. So the ball has a velocity of 64. The units for our height are, it did not say, but we're going to just assume that it said feet per second. Okay, let's look at another example of this. The v of t gives the velocity of the ball, I'm going to add this part, in feet, after t seconds have elapsed. Interpret the first derivative, or so v prime of t equals negative 32. Okay, so again, the first derivative is that slope, okay? So it's the change in y over the change in x. So the y value is in terms of velocity. So this is going to be the change in velocity over the change in seconds, so in the time. So if I were to go through and put units here, velocity, the units for velocity are feet per second. We found that on the last one. And the time is seconds. So if I went through and did some dimensional analysis, I've got feet per second divided by second. So dividing, if I'm dealing with fractions, dividing by a fraction, you multiply by the reciprocal. So the reciprocal of seconds is going to be 1 over seconds. So that gives me feet per second squared is going to be what my units are. So what this means is that if this is just always negative 32, it doesn't matter what input value you put in, that means that the acceleration of the ball, because we've got, remember we learned back, we've got this is our first, this is our position function. The derivative of that is the velocity function, and then the derivative of that is the acceleration function. Okay, so the acceleration of the ball is always negative 32 feet per second squared. Okay, here's another one. P of t gives the population of rabbits t months after January 1st. Find and interpret p prime of 4 equals 100. Okay, so first I always look at units. So if I'm finding that derivative, again, I'm finding the slope, change in y over the change in x. So the y value is the number of rabbits. So the change in rabbits over the change in months. So how many months has elapsed? Okay, so 4. If t is 4, that's going to be 4 months after January. So 4 months after January is going to be on May 1st. So we're treating January like it's 0. So on May 1st, the rabbit population is increasing at a rate, because again, a derivative is always the rate of change, of 100 rabbits per month. All right, from now on, we're going to use S of t to denote the position of an object in respect to time, V of t to represent the velocity of an object in respect to time, and A of t to represent the acceleration of an object in respect to time. So I kind of showed and alluded this earlier. So it means that the first derivative of the position is always the velocity, and then the derivative of the velocity function is the acceleration function. The displacement in meters of a particle moving in a straight line is given by s equals t squared minus 8t plus 18, where t is measured in seconds. Find the average velocity over the time interval 3, 4. Okay, so we have our position formula, and this is in terms of meters. So when I find that velocity and I'm finding that average velocity, this is going to be finding that average rate of change. So the slope of the secant. So if I was to look at this using this formula, v of t plus h minus v of t over h, we'd have the velocity of 3 plus 1, that h is going to be 1 because 4 is 1 away, minus v of 3 all over 1. So I get v of 4 minus v of 3 over 1, which gives us, when I substitute 4 in for t, I get 2. When I substitute 3 in for t, I get 3. So the answer is -1. So we need to put this in a sentence, and we need to make sure that we're using appropriate units. So the average velocity over the interval 3, 4 is -1. And let's figure out our units. So we've got the change in y, which is going to be in terms of meters, per the change in x. So those x values, that input value was t, which was seconds. So if we're finding that average velocity, that's just finding the secant that goes between those two x values. So I just used this formula for finding the slope of the secant line. All right, let's look at another part of this. If we were trying to find that instantaneous velocity when t equals 4. So instantaneous velocity, that's going to be finding the derivative of our original function. I can write this as v of 4 since the derivative of that displacement function or position function is the velocity function. Okay, so let's use the limit formula for this. So h approaches 0 of a, which is 4, plus h minus s of 4 all over h. So I'm going to go over here to figure out what s of 4 plus h is. So that's going to be 4 plus h squared minus 8 times 4 plus h plus 18. So 4 plus h squared again is 4 plus h times 4 plus h. And then this is going to give us 16 plus 8h plus h squared minus 32 minus 8h plus 18. So those 8h's are going to cancel. 16 minus 32 is -16, plus 18 is a +2. So this is going to become h squared minus or plus 2. Okay, and we found earlier s of 4, so when I substitute 4 in for t, I end up getting 2. Okay, so this is going to give me, when I go to substitute those values in, the limit as h approaches 0 of s of 4 plus h, which I just found was h squared plus 2, minus s of 4, which is 2, all over h. So the limit as h approaches 0, those are going to cancel, and I'm left with h squared over h. The limit as h approaches 0 of h. And now at this point I can actually substitute that 0 in. So when I do that, I'm going to get 0. And if we were looking, we need to make sure that we have our units. So we had meters per second. So the instantaneous velocity when t equals 4 is 0 meters per second. Let's look at one last example. A ball is launched vertically into the air from the ground with an initial velocity of 96 feet per second. Its height, s of t, equals 96t minus 16t squared. Find and interpret the following in the context of the problem, including units. So to find s of 4, that just means to go into this position formula or displacement formula, if you want to call it that. And anywhere you see a t, we're going to replace it with a 4. And we end up getting 128 in terms of units. So this is the displacement, so how far you are, so we're talking about feet. So we'd say after, what this means is after 4 seconds, the ball is 128 feet high. If we had to find s prime of 4, so this is finding the velocity when the time so the velocity at 4 seconds. So what is that speed of that ball? What is the velocity of the ball at 4 seconds? So if we were to do that, let's go through. So I'm going to go through this formula, the limit as h approaches 0 of s of 4 plus h minus s of 4 all over h. So the limit as h approaches 0 of, so if I substitute in 4 plus h here, I'm going to get 96 times 4 plus h minus 16 times 4 plus h squared minus s of 4, which I just found was 128, all over h. Okay, if we go through and FOIL this all out, we're going to get the limit as h approaches 0 of 384 plus 96h minus 16 times 16 plus 8h plus h squared when I FOIL out 4 plus h squared minus 128 all over h. So that gives me the limit as h approaches 0 of 384 plus 96h minus 256 minus 128h minus 16h squared minus 128 all over h. Holy moly. All right, when I go through and simplify this, you're going to be left with the limit as h approaches 0 of negative 32h minus 16h squared all over h. So now at this point, I can actually factor an h out. So I'm left with h times negative 32 minus 16h all over h. So those h's will cancel. I'm going to end up going up to here. So that equals the limit as h approaches 0 of negative 32 minus 16h. So now when I substitute in that 0 for h, I'm going to get negative 32. And in terms of these units, when we're talking about velocity, so it's again, this is the slope of that function. So the change in y, so the y is the feet over the change in x, or when our input value is seconds. So negative 32 feet per second. So this means the velocity of the ball after 4 seconds is negative 32 feet per second. And at this point, you might be wondering, why is it negative? Well, it's negative. That shows the ball is falling. So velocity has the direction and the speed. So it's falling at a rate of 32 feet per second is what that means.